In April of 1988, in a joint effort between the Sandia Laboratories, the United States government, and the Japanese Muto Institute of Structural Mechanics, a fully functioning F-4 Phantom jet crashed into a reinforced concrete wall at 480 miles per hour. Nuclear wars. Ever since the first nuclear power plant was built in June of 1954 in Obninsk, Russia, the ever-looming fear of a devastating wipeout that could impact the world has been present. But although there have been a few significant incidents involving nuclear reactions, such as the Chernobyl and Kystym disasters or the Windscale fire, these episodes have never originated from planned terrorist activity. This is mainly because dozens of government agencies from around the world have taken precautionary measures to prevent a disastrous nuclear event, building heavily guarded nuclear facilities protected by thick walls. But in 1988, the United States government wanted to test the effectiveness of the reinforced concrete used in the construction of their nuclear facilities. The Sandia National Laboratories, founded in 1949, are among the National Nuclear Security Administration's research and development laboratories. Their primary objectives are developing, engineering, and testing the non-nuclear components of nuclear weapons and high technology. In the late 1980s, Sandia Laboratories came up with an idea to explore the concrete's strength through a highly unusual test. The test. To explore the strength of the concrete structures, Sandia Laboratories came up with the idea of launching a McDonnell Douglas F-4 Phantom II supersonic jet at full speed into a rectangular wall of reinforced 12-foot thick concrete. The wall would weigh 469 tons, 25 times heavier than the aircraft, and be placed on an air-bearing platform that enabled free movement in the direction of the impact. In April of 1988, the test was performed at the Sandia Laboratories premises in California. Under the terms of a contract signed with the Japanese Muto Institute of Structural Mechanics, the engineers installed 16 high-speed framing cameras to record the crash, shooting up to 2,000 frames per second. The fully functional F-4 Phantom weighed 42,000 pounds and was filled with water to simulate its fuel weight. The jet interceptor was loaded onto a rocket sled and accelerated to a speed of about 480 miles per hour with the help of rocket boosters. It then impacted the reinforced concrete wall head-on, and the footage shows the crash from several angles. Results. The impact atomized the aircraft's tail, fuselage, and canopy into billions of minute pieces, disappearing in a cloud of smoke and fire. Parts of the destroyed aircraft and bits of crushed engines landed on adjoining terrains. The only section of the Phantom that remained intact was a small piece from a wing that missed the wall entirely. The concrete block only suffered minor structural damage, with perforations no more than 2.4 inches deep. The target was supported by airbags, which enabled it to move with the objective of measuring the force of impact. The crash's potency pulled the block back a mere 1.82 meters. It still was a high-energy impact. As the aircraft's engine exploded into small pieces, it experienced an acceleration force of over 700 G-forces. A year after the test, Walter von Riesemann, Sandia's Containment Technology Division supervisor, spoke at the International Conference on Structural Mechanics in Reactor Technology about the test's importance. Quote, "The crash data are going to give us an unprecedented ability to predict the impact force when an aircraft crashes into a building. We'd previously done some fairly accurate computer analysis, but the computer models were untried on the real thing. Not anymore." Sandia officials later added that although these kind of tests might seem superfluous, they are in fact highly critical. Quote, "Researchers need to estimate the structural response of a building in such an accident. To do that, they must know how the impact force changes throughout the brief time the crash is in progress." In the end, the 1988 experiment proved that the reinforced concrete walls to protect the US's nuclear reactors could stop a standard jet from inflicting grave damage on their contained atomic weapons, averting a local atomic disaster.